Welcome to myprojectbazaar.com. Our product title is Adaptive Fuzzy Sliding Mode Control using Supervisory Fuzzy Control for 3 DOF Planner Robot Manipulators. Let us see about the abstract. Before that, in this process we only done figure 1, 2 and 6 and also corresponding control diagram only developed. That is for the client requirement, so that only we developed, and also corresponding output only we here provide, and also this process only we did in this overall product. Next abstract. The control of an industrial robot includes non-linearities, uncertainties and external perturbations that should be considered in the design of control laws. This proposed system presents a control strategy for robot manipulators based on the coupling of the fuzzy logic control with the so-called sliding mode control (SMC) approach. The motivations for using this kind of control in sliding mode control in robotics mainly relies on its appreciable features such as design simplicity and robustness, yet the chattering effect typical of the conventional sliding mode control can be destructive in this proposed system. This problem is suitable circumstance by adopting an adaptive fuzzy sliding mode control, that is AFSMC approach, with a proportional mode control and integral derivative PID sliding surface. For this proposed approach we have used, and also a fuzzy logic control to generate the heating control signal. Moreover, the output gain of the fuzzy sliding mode control is tuned online by the supervisory fuzzy system, so the chattering is avoided. The stability of the system is guaranteed in the sense of the Lyapunov stability theorem. Numerical simulations using the dynamic model of a 3 DOF planner rigid robot manipulators with uncertainties, so the effectiveness of the approach in trajectory tracking problems. The simulation results that are compared with the result of conventional SMC with PID sliding surface indicate that the control performance of the robot system is satisfactory, and the proposed AFSMC can achieve favorable tracking performance, and it is robust with regard to uncertainties and disturbance. Control diagrams such as figure 1 and 2.6 only implement this process. Next we see about the flow diagram of our process. This is our flow diagram. In this flow diagram mainly three kind of systems we used. One is the sliding mode control system, another one fuzzy logic control system, another one PI control system. So in the control system of sliding mode control system is a nonlinear control method that alerts the dynamics of a nonlinear system by applications of a discontinuous control signals that forces the system to slide along a cross section of the system's normal behavior. That state feedback control that loss is not a continuous function of time. Instead, it can switch from one continuous structure to another based on the current position in the state space. Hence, sliding mode control is a variable structure control method. The motion of the system as it slides along these boundaries is called a sliding mode, and the geometrical locus consisting of the boundaries is called the sliding surface. And next one is the fuzzy control system. It is a control system based on fuzzy logic, a mathematical system that analyzes analog input values in terms of logic variables, then take and continuous values between 0 and 1. In contrast to classical or digital logic, which operate on discrete values of either 1 or 0. Fuzzy logic is widely used in the machine control. The term fuzzy refers to that fact that the logic involved can deal with concepts that cannot be expressed as the true or false, but rather it's partially true. Next one is the PI control. As the name suggests, it is combination of proportional and an integral controller. That output also called the actuating signal is equal to the summation of proportional and integral of the error signal. Now let us analyze proportional and integral controller mathematically. As we know, in the proportional and integral controller, output is directly proportional to the summation of proportional of error and integration of the error signal. Writing this mathematically, and also that. Next we see about the running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB window and create a new model file. So and also this data is given, and next one is the open the main model file. After model file we creating the arrange the elements from the given base paper control diagram only. In this our flow diagram we using only control diagram only consider. So as per the flow diagram we develop the arrange the elements from the simulating library browser. After arranging that we connect the sim out block. That sim out block purpose is that value is fit into the workspace. After that workspace is fit into the M file coding. So from the M file coding we draw the various output waveforms. The first one is the trajectory of the joint 1 waveform, and that is drawn between trajectory of joint and time. And next one is the trajectory of time bar various process. First one is the sliding mode, fuzzy sliding mode control, adaptive fuzzy sliding mode control, and final is the desired trajectory. And next one is the trajectory of joint 2 output waveform, and this is the corresponding comparison output of the trajectory of joint 2, and this is the trajectory of joint 3 output waveform, and also this is the corresponding comparison of the trajectory of joint 3 output waveform. This is all compared with SMC, FSMC and adaptive fuzzy SMC with all the PID sliding surface, and also this is the desired trajectory. And next one is the fuzzy control. Here we create a fuzzy control for this. So this is the input membership function. So we assign the input membership function. Next one is the second membership function of the input, and this is the output membership function. From the using of this we check the rules and surface. So from that rules the waveform will be shown. So here we can see the waveform of the rules. Next one we can see the surface waveform. So click that surface, the output surface waveform will be shown here. So using a fuzzy sliding mode control, the output efficiency will be increased. Thank you for watching this video.